In this lesson, we are going to discuss 4 experiments. 4 experiments we'll do in our head and try to understand what will happen. A capacitor is charged to a potential difference V. The capacitor is having capacitance C. Now, after charging the capacitor, in experiment 1, we disconnect power supply. So the battery is removed, disconnected. Once the battery is disconnected, charge is trapped. It cannot run away anywhere. So charge will remain constant. Now we increase the separation D between the plates. We want to understand what will happen to these 4 parameters: the charge Q, the electric field E, the potential difference V between the plates, and the capacitance C. Now what will happen to charge? Charge is trapped because the power supply is no longer connected. So charge cannot run away anywhere. So because charge is trapped, it will remain constant. What about the electric field? Electric field is given by sigma by epsilon naught. Sigma is charge per unit area. Charge is not changing, area of the plates is not changing. So therefore, electric field will also remain constant. What about the potential difference between the plates? Electric field is not changing, but we are increasing the distance D between the plates. V equal to ED. So if D increases, V will increase. And what happens to capacitance? Capacitance is given by epsilon naught A by D. Here epsilon naught and A are constants. D is increasing. So capacitance will decrease. If you look at the equations that you have written here, only one of the parameters we have kept it variable. Other things are constant. And based on that, we have taken a decision whether our dependent variable will increase or decrease. So you must write the equation like that. If both these things are changing, there is no way you can make out whether this will increase, decrease or remain constant. Here E is constant, D is variable. So if D is increasing, then V has to increase. In experiment 2, we keep the distance between the plates constant. We are not changing D. But power supply is disconnected. So power supply is disconnected. The capacitor is initially charged. Power supply disconnected. Now we insert a dielectric. So now we want to understand what will happen to charge, electric field, potential difference between the plates, and capacitance. Charge, electric field, V, C. Now again, charge is trapped. The moment the power supply is disconnected, charge cannot run away anywhere. So charge is trapped, it remains constant. But now, the electric field will decrease by a factor of K. Okay, whenever a dielectric is present, the electric field becomes weaker by a factor K. So this electric field is now sigma by K epsilon naught. Okay, whenever a dielectric is present, in every formula replace epsilon naught by K epsilon naught. So since K is downstairs and K is more than 1, the electric field will decrease. What about the potential difference between the plates? Now the distance between the plates is not changing. Electric field is becoming weaker. So V will decrease. So V decreases. And what about capacitance? Capacitance is now given by K epsilon naught A by D. Epsilon naught has become K epsilon naught because of dielectric. And since K is more than 1, capacitance will increase. So when the power supply is disconnected, charge remains constant. That is most important to remember. Now in experiment 3, we are going to keep the power supply connected. And when the power supply remains connected, the potential difference V will remain constant, because the job of a power supply is to maintain a constant potential difference across its terminals. So this power supply remains connected. And now in the third experiment, we increase the separation D. So now again we are increasing the separation D between the plates. But now we are keeping the power supply constant. Power supply will maintain a constant potential difference across its terminals. Now we want to see how these parameters will change. Charge, electric field between the plates, potential difference between the plates, and the capacitance of the capacitor. Now since the battery remains connected, battery will maintain V, so V will remain constant. So charge remains constant. Not charge, V remains constant. Now what happens to capacitance? Capacitance depends only on geometry. So capacitance is given by epsilon naught A by D. Since D has increased, capacitance will decrease. So capacitance will decrease. What happens to charge? Now charge we must write in a manner so that only one variable is there in the formula. Other things are constant. So here capacitance has decreased. Voltage, the potential difference between the plates, is remaining constant. So therefore Q we can write as CV. V remains constant. Capacitance is decreasing. So charge will decrease. What about the electric field between the plates? Electric field is given by sigma by epsilon naught. Now sigma is charge per unit area. Therefore, as charge is decreasing, the electric field also must decrease. So only the voltage, the potential difference between the plates remains constant. All other parameters Q, E and C decrease. Now in the last experiment, experiment 4, the power supply remains connected and we insert the dielectric. Now because the power supply is remaining connected, the potential difference between the plates will not change. So V will remain constant. Now capacitance is given by K epsilon naught A by D. Since K has come upstairs and that is more than 1, capacitance will increase. Charge and electric field. Now charge is given by C into V. C has increased by a factor of K. Therefore charge will also increase by that same factor. And the electric field, which is given by V by D. V is not changing, D is not changing. So electric field will remain constant.